Here are the trickiest problems from the SAT Maths section of the official test practice test 5. This problem says the result of increasing the quantity x by 400% is 60. What is the value of x? So the easy mistake here is to just say 400%, that's just 4 times x. 4 times x, which is equal to 60. We get x is equal to 15, but this is actually incorrect. We have to think. Let's break this down. Let's say we're trying to find 100% of 10. We can pretty confidently say this is 20. But notice how we didn't just say 100% and we multiplied 10 by 1 to get 20, because that would not give us 20. We have to break it into parts. So we have to keep the original quantity, x, and then we have to add our percent, 400 divided by 100. It's per the cent, which is 100, and we get 4. So we'd have to add plus 4x to this value to get 5x. And then this is equal to 60. We can solve 5x is equal to 60 by just dividing 5 from both sides. We get x is equal to 12. Thus, our answer is A. This next problem says, in the xy plane, a circle has center C with coordinates h, k, and points A and B lie on the circle. They lie on the circle. Point A has coordinates h plus 1 and k plus the square root of 102, and the angle ACB is a right angle. What is the length of AB? So our first step, we can draw out this circle. So we know, sorry, this is a poorly drawn circle, but we know the center is HK, and then the point A is H plus 1, and K plus square root 102. We also know that this is a right angle, and B is on the other end of that. So we could put B right here. And then our goal, the question is asking us to find the length of AB. So first thing I noticed right away is that the distance from the center to each coordinate is both equivalent. So that means we can use the Pythagorean theorem to find what the AB is equal to. So we can say r squared plus r squared is equal to AB, which is we can say AB squared, and then we'll say 2r squared equals AB squared for the distance of AB. We square both sides and we get the square root of 2 times r is equal to AB. So basically right now we have this value r that we don't know what it is, but we can find r. We can use the distance formula. Basically for this, we are going to find the distance from the point A is right here, and from point C. So we can use this formula. The formula basically says the square root of x1 minus x2 squared plus y1 minus y2 squared is equal to the distance. So we can plug these values in. Our h plus 1 is one value, and then we'll subtract the h from the center. We'll square this, then we'll add our k plus square root 102 minus the k from the center and square that value. This then simplifies to 1 squared plus 102. We get 103 from this, and that is our distance. So 103 is basically equal to our r. And so we can then use this equation that we found right here, and we can plug in the r. We can get 2 times the square root of 103 is equal to the length of AB. We can multiply these into one square root, and we get the square root of 206 is equal to AB, and thus we have found our answer, which is A. This next problem says for an electric field passing through a flat surface perpendicular to it, the electric flux of the electric field through the surface is the product of the electric field strength in the area of the surface. A certain flat surface consists of 2 adjacent squares, where the side length in meters of the larger square is 3 times the side length in meters of the smaller square. An electric field with the strength of 29 volts per meter passes uniformly through the surface, which is perpendicular to the electric field. If the total electric flux of the electric field through the surface is 4,640 volts times meters, what is the electric flux in volts times meters of the electric field through the larger square? The biggest thing with this problem is it looks super intimidating. You do not need physics knowledge on the SAT math section. So with that, we can basically just use our math skills to solve this. We can draw it out. There's an adjacent square right here to a larger one here. And so we know the side length of the smaller one is just x, and then the bigger one is 3x. And the problem also says that the electric flux, we'll abbreviate this EF, is equal to the electric field strength. So we'll just say electric field strength abbreviated as S. And it's a product of S times the area of the surface, S times area. So it says the electric field through this surface is 4,640 meters. So this is basically this whole surface. So it's saying 4,640 volts per meter is equal to S times area. So basically, we're wondering what is the X. We're wondering what the X is. So we can start substituting into this equation to find what the X is equal to. 29 is the field strength, which it said right here. And then the area, we can find this by solving what this area is equal to. Of course, we won't get what X, but once we plug it into, then we can find what X is equal to. So this is just x times x, which is x squared, plus 3x squared, because you're multiplying 3x times 3x, and we get 9x squared. So these all go together to get 10x squared. And so we can multiply this together. We get 10x squared. 4,640 divided by 290 is actually just 16. So this makes the problem a lot easier. If we take the square root of both sides, we get plus or minus 4 is equal to x, but we can only have a positive length, so 4 is equal to x. Thus, we can say that the side length of one of these is equal to 4. So the question is, what is the electric field strength of this larger square? So we can then use the equation with our new values that we found. We now know, we can plug in 29, which is the volts per meter, but we now know the area. We now know something new. Area is equal to 3x squared. We knew this, but now we can substitute x in, and we get 12 squared, and area is equal to 144. So we can multiply 29 and substitute 140. We can substitute this value in for the area, and we get 29 times 144. We do 29 times 144. We get 4,176, and that is our answer. Thank you for watching.